So, Year 12's doing chromatography, and this is about separating something out into its separate components. The easiest way to explain that is to do a simple experiment using paper. I've got some paper, my analyte, which is my connector pen, chuck that into some water. What's going to happen here is you're going to have a mobile phase, which is your water in this case, and it's going to be absorbed through your stationary phase. Stationary phase in this case is going to be our paper. As our water mobile phase gets absorbed through our stationary phase, our paper, it's going to start to interact with our sample, which is our connector pen. So the stuff that's in this connector pen, some of it's going to get dissolved in our mobile phase, and it's going to travel with it as it moves up. Our stationary phase is also going to interact with our connector pen, and it's going to try and hold it back. Okay, so the stationary phase is going to try and hold the connector pen in place, and the mobile phase is going to try and move it. The way it does this is through intermolecular bonding and intermolecular forces, forming dipole-dipole hydrogen and dispersion forces. So our mobile phase here is polar because it's water, so therefore as it moves through, it's going to try and interact with the polar molecules and take them along with it through either dipole-dipole or hydrogen bonding. Our stationary phase, as I said, is going to try and take it back. As you can see, this is starting to separate out now, and I'm going to start to do a bit of a time lapse to make it go a bit faster. So as you can see, some time has passed, and now you can see this texture has been separated out into two main components. One nice bright blue colour and a beautiful pink colour as well. Our blue colour has travelled up further, and that is how you might identify these substances. The identity of these substances is calculated by something called an RF value, which is a measure of how far it's gone compared with how far the actual full mobile phase has gone. This, in Year 12, is also used as the fundamental principles of HPLC, which is a bit more of a fancy type of chromatography. Let's have a look at how this can be used to explain that.